أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين. So today we'll be looking at connectionism. It's part of computational neuroscience. Before we begin, just check the audio. Should be working, inshallah. Right, so we're going to explore connectionism, as I mentioned, and this is an interesting component of computational neuroscience. Just to recap, we were looking at the visual system a couple of streams ago, which we are still continuing, of course, but this was of peculiar interest because I have not actually stepped into computational neuroscience as deep as cognitive neuroscience and neuropsychology. So the idea of jumping into computational neuroscience again came from the interesting paper I read. And if you recall, this model, input, hidden output, was something proposed by McClelland and Rumelhart in the 80s. And just to give you a review, a recap, this is what we were looking at. So as you can see, there's an input layer, hidden layer, output layer. Okay, and this is coming out here. And thereafter we have identity, an object, and so on and so forth. So this one's going to be a bit different because we shall be speaking about the idea of connectionism. Okay, so where did the page go? Right, so connectionism is an approach to the study of human mental processes and cognition that utilizes mathematical models known as connectionist networks or artificial networks. So it's an approach. So It's more tied into a concept, a philosophical slash cognitive concept, one would say. So an approach. By the way, my style of learning something is I pick 2 to 4 sources, and based off of those sources, I will then dive deeper into it. Okay, that allows me to pick up information from various sources, of course, which offer different viewpoints, opinions, and also theories that support or go against it. And that's exactly what Islam teaches us as well. In any case, it's an approach to the study the human mind of the human mind and mental processes, okay, and cognition that utilizes mathematical models known as connectionist networks or artificial neural networks. Right, so this is quite interesting. Now, connectionism has had many waves since its beginnings. The first wave appeared in 1943 with Warren McCullough and Walter Pitts, both focusing on comprehending neural circuitry through a formal and mathematical approach. Frank Rosenblatt, who published the 1958 paper, The Perceptron, a probabilistic model for information storage and organization in the brain. This is one of the foundational scientific papers for large language models, or otherwise known as LLM. LLM, for example, you have ChatGPT, Claude, Gemini, so on and so forth. While working at the Cornell Aeronautical Lab, so aerospace has had a huge role to play in the development of such a theory. The first wave ended with the 1969 book about the limitations of the original perceptron idea, written by Marvin Minsky. Interesting guy. He's one of the pioneers of AI. Now, the reason I'm actually using TikTok as well for this, just to show you that Wikipedia is not all fake necessarily. There are, most of the times, I would argue 95% of the time, it's an extremely useful source for getting preliminary readings so you understand concepts, theories, histories, and so on and move forward. Anyway, and Seymour Papert, which contributed to the discouraging major funding agencies in the US from investing in connectionist research. So the first wave ended in 69, lasted about 40 or 10 odd years. But the limitations of the original idea, which contributed to the discouraging major funding. Connectionist approach, interesting. With a few noteworthy deviations, most connectionist research entered a period of inactivity until the mid 80s. The term connectionist model was introduced in a 1980 paper in the journal Cognitive Science by Jerome Feldman and Dana Ballard. This is very interesting. Okay, the second wave blossomed in the 80s following a 1987 book about parallel distributed processes. Okay, by James McCullen, David Rumelhart, which introduced a couple of improvements to the simple perceptron idea, such as intermediate processes known as hidden layers. Right, so there's a process in the middle along the input and output units and used a sigmoid activation function. So a sigmoid function is any mathematical function whose graph has a characteristic S-shape or sigmoid curve. Activation in artificial neural networks, the activation function of a node is a function that calculates the output of the node based on its individual inputs and their weights. Non-trivial problems can be solved using only a few nodes if the activation function is non-linear. Okay, fascinating. Let's very briefly step into this. Looking at sigmoid, here we go. Sigmoid linear unknown over 1 plus e to the power negative x exponentially linear. So, Gaussian. So, just to reiterate, in artificial neural networks, the activation function of a node is a function that calculates the output of the node based on its individual inputs and their weights. Non-trivial problems can be solved using a few nodes if the activation function is nonlinear. Modern activation functions include the logistic sigmoid function used in the 2012 speech recognition model developed by Hinton. There are ELU used in 2012 AlexNet computer vision model. AlexNet is a convolutional architecture developed for image classification. 2015 ResNet model version and GLU. Context is not but is a language to BERT dramatically improved the state of the art for large language models. As of 2020, BERT is ubiquitous baseline in natural language processing LLP NLP experiments. Hmm, interesting. Interesting. So a lot of layers to this. So activation function in a done that. Okay. Aside from empirical performance, activation functions also have mathematical properties. So, nonlinear. When the activation function is non-linear, then a two-layered neural network can be proven to be a universal function approximator. This is known as universal approximation theorem. The identity activation function does not satisfy this property. Right, because it's not okay, yeah. When multiple layers use the identity activation function, the entire network is equivalent to a large layer model. Okay, this is interesting. Okay, so just going back here, instead of the old all know nothing function, their work built upon that of John Hopfield, who was a key figure investigating the mathematical characteristics of sigmoid activation functions. From the late 80s, mid 90s, connectionism took on an almost a revolutionary tone when psychology and so called group fashion AI, or GOF AI, some advantages of the second wave connection approach included its applicability to a broad array of functions, structural approximation to biological neurons, low requirements for innate structure, and capacity for graceful degradation. Its disadvantages included the difficulty in deciphering how ANNs process information or account for the compositionality of mental representations and a resultant difficulty explaining phenomena at a higher level. Okay, the current third wave has been marked by advances in deep learning. Machine learning, deep learning focuses on utilizing multi-layered I'm going to stretch the screen. Would that make it better? Okay. Which have made possible the creation of large language models. Okay. The success of deep learning networks in the past decade has greatly increased the popularity of this approach, but the complexity and scale of such networks has posed them with increased interpretability problems. Generally, central connectionist principle is that mental phenomena can be described by interconnecting networks of simple and often uniform units. The form of the connections and the units can vary from model to model. For example, units in the network could represent neurons, and the connections could represent synapses. Chain. Mental phenomena. How is that even possible? Doesn't make any sense, but I'm sure. Let's just consider it for a moment. Principle has been seen as an alternative to GOFAI, good old-fashioned AI. Classical theories of mind based on symbolic computation, but the extent to which the two approaches are compatible has been the subject of much debate since their inception. I do have the Stanford link open. I assume it's the same one. Yeah, it's cool. Okay. Central connectionist principle. So the main aspect here. So the central connectionist principle is that mental phenomena can be described not explained or proven by interconnected networks of simple and often uniform units. These are units that exist in the system. Interesting. Right. Okay. Internal states of any network change over time due to no signatures. Guess we'll continue tomorrow. Oh,